Welcome to part 4 of this series. In this video, we introduce the method of computing square and solve 4 examples. Hello math champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the 4th session of factorization, and in this session we focus on the method of computing square. Let's observe the expansion of a simple computing square x plus or minus m, or in parentheses squared. The relationship between the linear coefficient 2m and the constant m squared is that the constant m squared equals the linear coefficient 2m divided by 2 and then squared. Please note, the plus or minus sign here is to combine two formulas into one. It requires both sides of the equation take the same upper or lower sign. Now, if we have a quadratic and the linear terms x squared plus or minus bx, then what constant required of making the 3 terms a computing square? As just explained, the required constant showing in red here is b over 2 or in parentheses squared. Let's explain this topic by going through some examples. Example 1. Factorize 2x squared plus 4x minus 7. Here, the quadratic coefficient is not 1, so we need to take the number 2 out, and then every term of this expression needs to be divided by 2. In order to make a computing square, we need the constant 2 over 2 or in parentheses then squared, which is just a 1. After computing the square, we have 2 times open square bracket x plus 1 or in parentheses squared minus x over 2 close square bracket. Since 9 over 2 equals 3 over square root 2 or in parentheses squared, we have 2 difference of squares remain in the squared bracket. Then it is proceed with the formula of the difference of 2 squares, and finally we get the factorization done. Example 2. Factorize negative 2x squared plus 5x plus 1. After initial inspection, we can't find any common factor for all the terms, and it also can't be factorized using the cross product method because the linear term cannot be matched no matter how we do with the quadratic and constant factors. Therefore, we have to do this question with the method of computing square. First, we need to make the quadratic coefficient to 1 by taking out negative 2. And in this way, all the coefficients of this quadratic expression has to be divided by negative 2. Based on the linear coefficient, which is negative 5 over 2, it needs a constant negative 5 over 4 or in parentheses squared to make it a computing square. Since we add this number, we have to minus the same number to keep the expression balanced. And after being simplified, the term in the square bracket can be further factorized using the difference of 2 squares, and hence we get the factorization done. Example 3. Factorize 3x squared plus 6x minus 3 using computing square method. Since the requirement of doing this question is to use the computing square method, we just go ahead and take out the common factor 3 first, and then proceed with the required method. And finally, we have factorized this quadratic expression as displayed here. Example 4. Factorize ax squared plus bx plus c, where a is not equal to 0. Now we factorize a trinomial quadratic expression with coefficients a, b, and c respectively. Please note the only restriction here is a is not equal to 0, because if a equals 0, the expression is no longer a quadratic expression, and we cannot apply the method of computing square onto it. Since these coefficients are arbitrary constants, the result of this factorization can be regarded as a general solution to this type of factorizing problem. As usual, we divided all the coefficients by the quadratic coefficient a, and then add a new constant b over 2a, or in parentheses squared, to make the first 3 terms a competing square. After the remaining constant terms being arranged and simplified, it becomes b squared minus 4ac all over 4 times a squared, and hence we introduce you a new parameter named discriminant, which is equal b squared minus 4ac. Remember, it is a very important parameter which determines the number and nature of the quadratic roots as well as its graphic interpretation. As we see, when discriminant is greater than 0, the quadratic expression can be factorized in real number range as 2 different linear factors. When discriminant is equal to 0, the quadratic expression can be factorized as a times the repeated linear factors. However, when discriminant is less than 0, the quadratic expression cannot be factorized in real number. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.